In this video on beta function part 2, we are going to discuss second type of problems on beta function. In my last video on beta function part 1, we have seen beta function to be an integral from 0 to 1 of x raised to m into 1 minus x raised to n dx to be m plus 1 comma n plus 1. In the second type of problems, we will make a slight change and write the integral from 0 to 1 of x raised to m into 1 minus, instead of this x, we will write x raised to n whole raised to p dx and see how to solve this. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. In the first problem, we evaluate integral from 0 to 1 of x raised to 6 into 1 minus x square raised to half dx. Before we decide a proper substitution, please notice this 1 minus x square. In this, here there is x square and square of this higher limit is here. We will substitute x square equals 1t, that is t. So x will be t raised to half and dx half t raised to minus half dt. Because of this substitution, we will find the change in the limits of integration. When x is 0, t is also 0, and when x is 1, t is also 1. There is no change in the limits of integration. So the integration becomes from 0 to 1 t raised to half raised to 6 into 1 minus t raised to half, and in place of this dx we substitute this half t raised to minus half dt. This will be this half t cube minus half 1 minus t raised to half dt, which is t raised to 5 by 2. Now this is a beta function, so the integral will be half b 5 upon 2 plus 1 7 upon 2, 1 upon 2 plus 1 3 upon 2. In the second problem, we have to evaluate integral from 0 to 1 of x cube into 1 minus root x whole raised to 5 dx. Here we observe this 1 minus root x. We find that square root of this higher limit 1 is this 1. Therefore, we choose to substitute root x equals t, so that x will be t square and dx will be 2t dt. Let us check change in limits due to this substitution. When x is 0, t is also 0. When x is this 1, t is also 1. So there is no change in the limits of integration. The new integral will be from 0 to 1 of t square cube into 1 minus t raised to 5. In place of dx, we write this 2t dt. This reduces to this 2 t raised to 7 1 minus t raised to 5 dt, which finally becomes 2 times this beta function 7 plus 1 8 comma 5 plus 1 6. That will be 2 into gamma 8 into gamma 6 upon gamma 8 plus 6 gamma 14, which will be 2 7 factorial into 5 factorial upon 13 factorial. That will be 2 7 factorial into 5 factorial. 13 factorial will be 13 into 12 into 11 into 10 into 9 into 8 into 7 factorial into 6 into 5 factorial. This 7 factorial and 5 factorial cancels here. 2 ones are 2 threes are, which finally works out to be 1 upon 5/148. In the next problem, we evaluate integral from 0 to 2 x raised to 4 into 8 minus x cube raised to 1 upon 3 dx. We observe this 8 minus x cube, where we find that The cube of this higher limit is this 8. So we choose to substitute this x cube equals this 8t. So x will be cube root of 8 to t raised to 1 upon 3. After differentiation, dx will be 2 into 1 upon 3 t raised to 1 upon 3 minus 1 minus 2 upon 3 dt. Let us check change in limits of integration due to this substitution. When x is lower limit 0, t will also be 0, and when x is this higher limit 2, t raised to 1/3 will be 2 upon 2 1, so t will also be 1. So the integral becomes from 0 to 1 of 2t raised to 1/3 raised to 4 into 8 minus 8t raised to minus 1 upon 3, and for this dx we substitute this 2 upon 3 t raised to minus 2 upon 3 dt. So this finally reduces to 16 upon 3 from 0 to 1 t raised to 2/3 into 1 minus t raised to minus 1 upon 3 dt. That will be 16 upon 3, and this beta function be 2 upon 3 plus 1 5 upon 3 comma minus 1 upon 3 plus 1 2 upon 3. In general, we can say that number 1, if the integral involves 1 minus x raised to n, then we can substitute x raised to n equals t, so that x becomes t raised to 1 upon n. Number 2, if the integral is of the type from 0 to a x raised to m into a raised to n minus x raised to n raised to p dx, then we can substitute this x raised to n equals this a raised to n t, so that x becomes a t raised to 1 upon n. So in the evaluation of integral from 0 to 2 x raised to 7 into 16 minus x raised to 4 raised to 10 dx, we write this as 2 raised to 4 minus x raised to 4 raised to 10, and substitute as decided here x raised to 4 equals 2 raised to 4 t, that is 16t, so that x becomes 2 t raised to 1 upon 4, and dx equals 2 into 1 upon 4 t raised to 1 upon 4 minus 1 dt. So working further, as usual, we get 2 raised to 46 integral from 0 to 1 of t into 1 minus t raised to 10, which finally becomes 2 raised to 46 for this beta function part, b this 1 plus 1 2 comma this 10 plus 1 11. How to evaluate integral from 0 to 2a x raised to m into square root of 2ax minus x square dx. We write this part as x into 2a minus x whole raised to half, that is x raised to half into 2a minus x raised to half. So from this part we substitute this x equals this 280, and working on the same lines get the integral 2a raised to m plus 2 from 0 to 1 t raised to m plus half into 1 minus t raised to half dt, which finally will be 2a raised to m plus 2, and for this beta function b m plus half plus 1 m plus 3 upon 2 comma this half plus 1 3 upon 2. In the next evaluation of integral from 0 to 2a x square root of 2ax minus x square dx, as usual for this part as discussed above, we substitute x equals 280, and further working on the same lines we get 2a raised to 4 integral from 0 to 1 t raised to 5 upon 2 into 1 minus t raised to half dt gives us 5 upon 8 a raised to 4 pi. In the next problem, if m and n are positive integers, we have to show that integral from 0 to 1 of 1 minus nth root of x raised to m dx is m factorial into n factorial upon m plus n factorial. Observing this 1 minus nth root of x, we will substitute this nth root of x equals t. So x will be t raised to n dx equals n t raised to n minus 1 dt. After substituting the values and further simplification, we get I equals n integral from 0 to 1 of t raised to n minus 1 into 1 minus t raised to m dt will be n for this beta function be this n minus 1 plus 1 n comma this m plus 1, which will be n into gamma n into gamma m plus 1 upon gamma n plus m plus 1. This will be n into gamma n will be n minus 1 factorial. Gamma m plus 1 will be m plus 1 minus 1 factorial upon n plus m plus 1 minus 1 factorial. So integral will be for this n into n minus 1 factorial, we can write n factorial into 1 minus 1 is 0. So this will be m factorial upon this 1 minus 1 is 0. So it will be m plus n factorial, which is what is required here. Now the problems based on this. The first is evaluate from 0 to 1 minus cube root of x raised to 11 upon 2 dx. We have to put this cube root of x equals t. So x will be t cube and dx 3t square dt. After this substitution and simplification, we get integral 3 from 0 to 1 of t square into 1 minus t raised to 11 upon 2, which will be 3, and for this beta function be 3 comma 13 upon 2. Second example is evaluate integral from 0 to 1 of dx upon square root of 1 minus x raised to m. Here also we can substitute for this x raised to m t. So x will be t raised to 1 upon m and dx 1 upon m t raised to 1 upon m minus 1 dt. After substitution and simplification, the integration becomes 1 upon m from 0 to 1 t raised to 1 upon m minus 1 minus t raised to minus half dt, which is 1 upon m, and for this beta function b, this 1 upon m minus 1 plus 1 will be 1 upon m comma this minus half plus 1 half. Before we sign off, let us revise the various substitutions that we have talked about. When the part of integrand is in the form x raised to m into a minus x whole raised to n, proper substitution would be this x equals 80. When it is x raised to m 1 minus x raised to n whole raised to p, it should be this x raised to n equals t, and when it is 1 minus nth root of x raised to m, proper substitution would be this nth root of x equals t. By these substitutions, the integral turns into from 0 to 1 x raised to m into 1 minus x raised to n dx, which is a beta function b, this m plus 1 comma this n plus 1. Friends, if you like this video, please click the like button. Share this video with your classmates. Don't forget to subscribe this channel. Make constructive comments to help improve my videos. See you in the next video. Until then, keep watching Number Collage. Thank you.